Alright, welcome to Chapter 12, Section 2, Representations of Three-Dimensional Figures. This is for Integrated Math 2, or IN 2. So I'm going to be reusing some of these videos from a previous video, so the problem numbers may not quite match up, although you will see a title at the bottom to let you know which number it's supposed to be. It's just kind of a time saver there. Alright, so just to get started here on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too. If there's more than one answer within the question, there's partial on there too. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a submit assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the submit assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click submit assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the gradebook when you click that button so that your teacher can see what you've been working on and hopefully it will improve your grade there. Alright, on the side we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Make sure you read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you, because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. Find the surface area of a rectangular prism. Be sure to include the correct units in your answer. So one thing we do want to pay attention to on this one, let's see if I can find it real quick. If we're looking at a rectangular prism, kind of like this guy, so it's a box, right? And if I look at the net for a box, which means that we break it open, and we've done this a few times in class, so I'll click play here so we can actually see it. So here it is, it's folding back up, but I can cut the box away and I can unfold it too so that I can actually see that it makes kind of this, a bunch of boxes, right? And this box here, or this rectangle matches this rectangle, because this would be the left and the right side. This, or the front and the back actually, if I thought about that a little bit more. This little one and this little one would be the left and the right side. This one in the middle is the bottom. This one in the all the way on the side here is the top, if you watch it fold again. So I can see there's the left, back, front, and then it was the right and the top. So it's made up of a bunch of rectangles. Well, if I want to know the surface area is the area all the way around. How much surface does it have? So I need to know the area of all the surfaces. So when I do this, I want to make sure that I'm looking at this box. I'm going to try to draw it real quick as a net. So I have this guy. It's a little bigger there, I think. Something like that. That's probably not quite right. I'm drawing these a little bit funky, but I'm being a little bit too picky about it here, I think. All right, so we have something along these lines, and then I'd need the top part extended out here. So I took this left side here, which has a length of 3 centimeters, and I just laid it down. And then this bottom part here, which is this area here, I folded this flap down. So this is 8 centimeters. And both of these are 3 centimeters, by the way. Doesn't matter which one, because if I folded these back up into the box, they'd both be on this corner. And then I have 4 centimeters over here on this one, which is the bottom line here. So this is 4 centimeters. So I need to be able to fill in all these boxes though, when I'm doing this. And one thing we need to remember about a rectangle is opposite sides are congruent. So if this side is 3, so is this side. If this side is 3, then I can go across the rectangle and this side is 3. And then same thing here. If this, because it's the height, this is 3, well this would be the other corner there. It's this back corner if I folded them back up. So this is also 3, and since I'm sharing here, I'll share here. I can go across. This guy would be 3 centimeters. And same thing, these are folded corners that would come together. So these are all 3. So now let's deal with the lengths going across here. Well, if this one is 4, and we think about all of these lengths going across this way, they would all have to be the same length in order for it to make this nice rectangular prism. So this would have to be 4 centimeters, 4 centimeters, 4 centimeters, and 4 centimeters. All of these would all have to be the same. And this line would actually be the one that comes all the way over here to meet with this side. When I fold this all the way back up, they would meet right there. Again, just kind of visualizing the net. How do I fill this in? And then we can also look at this 8 centimeters, same thing. This length down at the bottom would have to be the same on all these lines going in the same direction. So I'd have to have 8 centimeters, 8 centimeters, and 8 centimeters, like that. And it might be easier for you to picture the actual box here. I'm not super great at drawing boxes, but I can give it a try here. Like this. All right, something along these lines. So we had 3 centimeters, and we had 8 centimeters, and we had 4 centimeters. So here it is. So remember, if this is 8, then all of these are 8. I'll just put them in blue, going like that. All of those same lines would be 8. And then if this guy is 4, all of these same lines going in the same direction would also need to be 4, like this. So all the green ones need to be 4. And then I'll just leave these guys in red. So we have 3, 3, 3, and then my one dotted line back here is 3, right? So it just depends on which one's kind of easier for you to look at. Maybe the three-dimensional is a little bit easier to look at as far as, you know, how do the lines go around. So now let's go ahead and start calculating some of this out. So we're going to look at the different parts of the box. The front of the box and the back of the box, or rectangular prism, are going to be exactly the same. So if I have the area of the front, I can just multiply that by 2. One for the front, one for the back. So this is front / back. So it's a rectangle or a rectangular prism. That means all of the shapes are either going to be rectangular or cubes. If we had a square on any of these sides. We're not going to have a square on any of these sides because we don't have any sides that are all exactly the same. This is 3 by 4. Remember, green was 4. And this is 3 by 8. That's definitely not a cube. A cube needs to be the same length and width. So to find the area of a rectangle, we go length times width. So if I want to do the front or the back, I'm going to have 3 for the height, or I can say length and width if I'm thinking of it flat. So 3 times 8, or 8 times 3. So that equals 24. I have a front and a back, so I'm going to multiply by 2, so that gives me 48. All right, and then I have the left / the right side. So let's look at that. So if I look at the left side here, I have 3 and 4 for length and width. So that gives me, oh, I started writing at 3, dang it. 3 times 4 gives me 12. Remember, there's a left and a right, and they need to match because that's the idea of a rectangular prism. It's the same shapes across, or the same rectangles. All right, so that's 24. And then I also have the top and the bottom. So there's 6 sides in total. Here's one side, and then when I multiply by 2, that's 2 sides. Here's 4 sides, because I multiplied by 2, and then when I multiply by 2 on this last one, I'll have 6 sides. So it's a 6-sided figure. All right, so the top, I have the green 4, and I have the red 8, or blue, sorry, blue. I meant to redo that in blue, but the red line's still kind of there. So the blue line for 8 and the green line for 4. So 8 times 4 equals 32 times 2 for both top and bottom. They're both the same rectangle. I have 64. All right, so this is the surface area of kind of each matching group. To get the total surface area, I need to add them all together. So I'm going to have 8 and 16, because 8 plus 8 is 16. 4, 5, 6, 7, and then 7 plus 6 is 13. So 136, and this is going to be centimeters squared, not cubed. This is an area, meaning we're talking about length and width, which is exactly what we did a whole bunch of times, right? Length times width. We're not talking about the volume. We're not talking about what the box can hold, just the amount of space the flat walls take up, I guess, is a kind of visual way or a way to describe that. All right, so I have this squared, check. So this is the idea of surface area. We're just looking at the surface on the outside. How much area does it take up? All right. All right, so with this one, we're looking at the surface area of a triangular prism. So kind of same idea as the last one, except now we have triangles to deal with. So we kind of have to cut those in half. That's actually part of the formula there, right? So the area of a triangle oh yeah, I'm just losing my crazy mind because that's a big triangle. Area of a triangle equals 1/2 base times height, or length times width if we're thinking about a rectangle. So if I'm looking at the side lengths, and with the triangular prism, the two triangles are going to be the same size. So I have a base of 10 and a height of 24. So I have 1/2 base times height, right? So this is one triangle. Remember, I'm going to figure this out. That's only one, and then I'm going to multiply by 2 because I have a left and a right side that are identical. So that makes it easy. So actually, if I'm thinking through that, and I'm going to multiply by 2 anyway, can I just ignore this 1/2? Yes. Yes, I can. Because I would divide by 2 to get one triangle, but I actually have 2 of them, so I actually have both halves of kind of like a rectangle. That's where we get the area of a triangle. So I can actually just ignore this because I'm going to be multiplying by 2, so they cancel each other out. So I can just say the area of the triangles, both of them together, is 240. So that's part of my area. Now I have to do the rectangles. So I have this kind of top, like ramp part. This would be a very steep ramp unless it's kind of standing up on its end. But I have 16 by 26. So this is, I'll call this the top, I guess. So it's 16 times 26. That's one area. And then I have the back. And that's going to be 24 by 16, because this is also 16. This would be 16 as well. So 16 times 24, because that would be the back side and the bottom. And then I also have this bottom piece that's a little bit more square looking, but it's not quite square. So I have 16 by 10 there. So I have those 3 lengths. Those are all 3 different, so I'm going to have to multiply them all differently. So let's see what I could do. I could break this apart and do it kind of in pieces, or I could just write it out and multiply it, either way. Doesn't really matter. So this would be 36. This is going to be 12, 13, 14, 15, and then 6 and 2. So that gets me 11 and 4. So 416. So this one is 416. And this guy is going to be 2 less than that. So I could just take away 32 from this amount. That would actually, work just fine. So if I took 116 away, I'd be at 400. If If I took another 16 away, let's see, I'd be at 90, 86. So I'm going to be at 386. 384. Ha ha ha. I can subtract that. Because I'm taking 6 away, not 4 away. So that's the 6, and then 10 more would be the 90 piece. So this is going to be 384. I could have also just remultiplied them. That would have been fine. And then times 10, that one's definitely a little easier because I can just add the 0 on the end. All right, so I have my 4 pieces. This is technically 2 pieces just combined, right? So I have all 5 pieces of my triangular prism here, and I need to add them together. So I'm just going to kind of stack them up here. Make sure if you're stacking them up, be very neat about it. Make sure the columns are nice and neat so that you can add straight down. So I get 10, 4, 5, 6. 6 plus 6 is 12. 12 plus 8 is 20. And then that's 4. Another 4 is 8. Another 4 is 12. So I get 1200. Wow, an even number there. All right, 1200, and this is area, so it's going to be yards squared. All right, so the whole idea here is just break it apart, kind of think about it. There's also programs that can help you break apart the net, like we did on the last one, things like that. So just kind of break the pieces apart. How do I calculate the area for each shape? And then make sure you combine them for surface area. So I'm going to close this guy down because we're actually going to look at this. So surface area of a cylinder, which is the name of this section, right? With the height of 9 yards. So we want to know, what is the surface area? And first of all, what is surface area? What does that mean? We've been dealing with volume. Volume has to do with, like, if I fill this can with liquid, what is it? How much does it hold? How much liquid can it hold? Well, when I'm talking about surface area, if I'm thinking about a can, it's all the surfaces on the outside that I can actually touch and the area that they take up. So I want to know the entire area of this space around the outside, and then also the 2 circles on the end, the 2 bases. So I'm just asking, what's the area all the way around? And this is definitely a very important question when we're talking about, say, advertising on a can, especially when we're asking about the surface area around the lateral surface area, if I'm being very technical here, because I would want to know how much surface do I need to cover to go all the way around the can. That definitely matters. You wouldn't want to cut it short. That would look really funny. So this is definitely one of those questions. Many companies use this idea of surface area. So we want to find the surface area of a cylinder with a height of 9 and a base radius of 4. Use pi, the value 3.14 for pi, and do not do any rounding. So let's take a look at the net really quick of a cylinder. So it's going to be something like that. If I were to cut this guy right down the center here and peel it open, here's what it would look like. I'd have 2 circles and a rectangle. So if I want the surface area, I want to find the area of each piece. Now, if I'm thinking about the circles, should they be the same size circles or different circles? I'm really hoping we answered same size circles, because the top of the can and the bottom of the can should be the same size circles. Now I know if we're looking at like a bottle of soda, that the top circle that you screw off the cap, that's not going to be the same as the bottom. But what we're talking about is kind of before it narrows to the top of the bottle there, it's going to be the same size circle. So, we're not getting so technical that we're going up to the top of the bottle there. We're more looking at the can. So same size circles. So whatever this area is, this one's going to be the same, right? So these guys will be the same area. So I can find the area of 1 and multiply by 2 because it's the same area. So sorry, that wasn't a very nice airbrushing for whatever reason. I don't know why the airbrush didn't come out a little nicer than that. I think I have the airbrush too small. That might be why. So normally it's a little bit more fuzzy looking like that, a little bit nicer. All right. So area of a circle, and we've been doing this a lot, so area is pi r squared. Area of a rectangle is length times width. All right, so now we need to apply a little bit more because we don't actually have all the information we need here, do we? So I know what pi is. Pi is 3.14. And I know what the radius is. That's 4. So I can find the area of the circles. I can definitely find the area. Sorry, that was an equal sign. I'll find the area of the circles, and once I find this area, I'm going to times 2 because I have 2 of them. So now let's think about the area of the rectangle before we go and calculate this. So length times width. Well, if I cut straight down this one, we're going to pretend like we're cutting right here where it says 9. That would be this guy here, 9 yards. So I already know that it's 9 yards this way, and I really hope this is not a soda can because 9 yards, holy cow. That is a big old soda can. So we're talking about something else, not a soda can. Definitely a very large cylinder here. So we have 9 yards here, but what's the width then? So if we think about it, when we were expanding that circle for a cylinder, if we picture this guy closed, it's going around the circle here, right? And if I open it, you can kind of see this is still the circle shape. And that's what this length is the length around the circle. So I need to know circumference as well, because that's what this distance is. So the circumference of a circle is 2 pi r. So circumference equals 2 pi r. So this is another equation that we need to know in order to complete this problem. So length is going to be 9, and then width is going to be 2 times pi times r, which is 4. So we have a couple of things to calculate here. So now let's go ahead and do this calculation. We're going to have 3.14 times 4 squared, which is 16. I'm just going to go ahead and type in 16 instead of having to type in the square. So, because 4 times 4 is 16, equal, why did I move from there? So this is 50.24. This is also 50.24, right? They're both 50.24 yards squared. This is squared. This is just an area. We're not finding volume anymore. We're finding area again. So I can go times 2, and I have 100.48. This is the area of the circles. Now I need the area of kind of the rectangle or the midsection there. So I'm going to go 9 times 2 times 3.14 times 4, so I have all 4 pieces here, equals 226.08. And that's, again, yards squared, because this had yards, and this also had yards on it for the radius. So yards times yards still gives yards squared, because it's still just an area. So this is the rectangle. So now I have both pieces, and I need to add them together. So 100.48 equals, and it says do not do any rounding again. Make sure you're paying attention to that. But it also says be sure to include the correct unit. It doesn't have it there. I need to make sure I select yards squared.